which is Manticore. So I have done absolutely nothing with Manticore yet, so I am about as blind as anybody else here is. I know that it is a symbolic execution tool. I know that Trail of Bits wrote it, and I have at least a reasonable grasp on how symbolic execution actually works, especially when it comes to using Z3. So let us just... Whoa, I don't know what these things do. What's the worst that happens? Oh, I hate those shortcuts are different. So what I just did there was I did Control-Shift-C to copy out of Firefox, because the terminal I'm using, Control-Shift-C will copy from, and Control-Shift-V will paste into. Problem is that in Firefox it's a different hotkey altogether, and it does completely different things, so bleh. Oh, and we didn't even copy it. So we want to sudo apt-get install some stuff. That's an interesting error. But metadata was ignored due to errors. I have a feeling this install is very unhappy right now, and I will probably be getting rid of it soon. Let's actually clear out all of these real quick. We already finished that. Q, exit, exit. So, where were we? So we ran that right there. We're gonna run this right here. We are already up to date. We then want to cd tools. This is the directory where I keep various tools that I might want. We're gonna run this thing right here. We are now installing Capstone with no binary. I don't know what it is, but apparently there's something special about it. So hopefully this does something cool. So we want to cd into examples, right? Cd Linux make. So Manticore basic. So the basics of how this works, at least my understanding, is that when we run Manticore basic, it is going to use Manticore to do exploration of standard in. So, I knew I should have moved over there. Linux, cd mcore. What all do we have here? Cat test 001.standard in. Okay. 2. So that symbol and a space did something different than at A. Oh, and we're supposed to pipe these into... Okay. Cat mcore test 1 standard in piped into basic. It is greater than 41. It is less than or equal to 41. Interesting. So what on earth did we just do? So this is the program. It's going to read... It will read up to 4 bytes into command. If command is greater than 41, it will print it out. Otherwise, it'll be less than, and it'll print that out. Makes sense? And what else did they tell us? So when we ran... this is the... No. So executor info. So we set up a loading program basic, workspace, mcore, generating test case number 1 for state number 3. Program finished correctly, program finished correctly. Okay. It looks like it basically just tried stuff and it worked. I'll buy that that's a thing. cat stir and compare. Sorry, terminal, I did not mean to kill you. Okay, so minimal toy example with input output. So we have buffer, we'll read 100 hex bytes into buffer. We then compare it with a zara zara, and we will then printf zara zara if it's there, otherwise not found. So if we do Manticore stir and compare. So I suspect what's going to happen here is that this is going to take a long time because it is trying to solve. Or not. Well, now I'm just entirely confused. I was expecting this to take much longer. So we're generating test cases. Okay. cd mcore for this thing. Star.standard in. Huh. Cat test 001.standard in. So that just sent a whole bunch of Z's. And then it sent whatever that is. That, so the first thing it did was it sent a whole bunch of Z's. That, oh, I'm guessing that, I assume that what it's doing is it's internally figuring out that we can get what we're looking to get. So what we're seeing here is we're slowly building up what this string actually looks like. So it took 8 test cases. And if we do find in mcore, which one was this? mcore 4 dash name slash star dot standard in dash exec dot cat that piped to dot slash stir and compare. This work? Oh, it's only one dash. What? That is not true at all. There we go. Nope. My cat not found. Okay. Why can I not do this? This is doing what I expect. You know what? Let's just do this the other way. Test 001.standard in piped to dot slash stir and compare. Not found. 2 not found. 7 8 zara zara. So if we actually just cat this, so this succeeds. Interesting. So what we did here, right, is we went through and we did symbolic solving to get to all of the different paths in this program, trying to figure out what exactly is going on. That's really interesting that it's that easy to do that I can just give it some stuff and it just kind of figures stuff out. What about, so CTF, events, plaid, big picture. So if I just do Manticore, big picture. I'm really curious what happens here, right? So if I understand the way Manticore works. Because I didn't do anything at all. I just said, here's a binary, go. It's going to try and see from standard in all the different paths in the program I can get to, and it's going to try and solve for them. What I expect here is that we are now a non-trivial program. We went from a very simple, we look at some stuff, to try and solve for everything. Like, this should come up with a ton of stuff. I kind of expect this to kind of choke and not be able to do much, but I'm not sure. So the part that I'm super excited about trying out is, oh, that scanf is going to kill it, isn't it? It's not going to have the slightest clue what to do inside of scanf. So one of the things, if you're not familiar about them, about how the symbolic execution stuff works, is they typically, the way that they work is they're going to try and create a unique input which gets you to someplace in the program. The way that, from my very brief understanding, Manticore does it is they're going to, like, I can give it a script here, and I can, oh, that's the wrong scripts. I want the ones in the example scripts. Examples, script. I want something like, sure, let's take a look at that. So this right here is basically saying they have a binary. In this case, there's some specific address you pass in as a second argument. We set up a hook, which is basically you tell Manticore to, at this point in memory, run this function. So we introduce sim, which is introducing symbolic value to this offset. The val is a new symbolic value of size 32. I assume that's 32 bits. We set up taint of taint ID. Taint ID is some tag we can give it. So we're basically setting up taint that is 32 bits in size and we can do stuff with. We then want to write an integer into memory, which is val and 32 bits. Okay, so we've basically, if I understand this correctly, we have said that here is something we care about. We want to write 32 bits into whatever this magic address is. There is then a has tainted operands function that's been defined here. For operand and operands, which is something, we're going to read that operand. If is symbolic and taint ID in the taint for that operand, we return true, otherwise false. We then hook. We can either hook every instruction or not. So we're going to hook on none to check taint. We then pull out an individual instruction. If it is a compare or a test, we check to see if there are tainted operands. If so, we print it out, which is what we got here. Basically what this is done is this is basically just done pretty simply. We said at this address, whatever this gross shell stuff does, we want to say that there's some symbolic value that we care about. There's some stack variable, because that's what we're doing here, right? Is we're saying that RBP minus CX, for whatever reason, we can control it. We're going to say that is the address we care about. So we're going to give it taint. We say that this is a symbolic value, and then we're going to write it into memory that way. And I am entirely talking about my ass right here, but my assumption is that the reason we do that is because by writing it in like this, as we follow on, we will know where it's used if it's tainted. So we did the introduce here to taint it. We then, on every instruction from here on out, for every instruction, we're going to check to see if it's a compare or a test. If it is, and one of the instructions is tainted, then we're going to print out the address of the instruction we're at. We're going to print out the mnemonic for it, and we're going to print out the op stir. So basically, we're going to just print out what each of those are, and in theory, we should be able to say that each of these is a EAX, and each of these we can control. Go verify. So what is this thing? So we were up here. Tools. I want Manticore. Examples. Linux. Where is this thing? Oh, this was introduce symbolic, right? Where is it? Examples. Script. Oh, no, that's not what I wanted at all. Oh. So I actually do have to run this thing. Okay, I can run this thing. Oh, hey, look at that. Unimplemented syscall. So apparently we got as far as the first test case where we hit a syscall that we can't do anything with and it died. That's unfortunate. How is this thing implemented? So I'm assuming the alarm stuff is what choked on it. That's unfortunate. But where were we? We come back over here. cd source, cd script, cd source. That's what we want to run. So we now have a state explorer binary. So source/state explorer.c. What is this thing actually doing? So we have our main here. If argc is less than 2, we're going to fill from standard in value. And then we do this stuff. Ew. Basically, what this thing over here is doing, so this is the script that they put together. And basically what they're doing here is they want to print out what are all the comparisons we can actually control in some way or other. So we check to see if value and OXFF is 0. If it is, we don't have one branch. Otherwise, we're going to check the next higher byte. Otherwise, we're going to go and check the next higher byte. Basically, we're checking to see if that low byte is 0, which is, I assume, this first one. Then we check to see if it's greater than 40 hex, which would print out this this comparison is the next place that the tainted data was used. Then there's another one, which I assume is down here. Yeah, it's probably this one right here. And then there should be a test to see if it's above 1,000 hex to print out this side or this side. We then check to see that there's another test. Now we're going back over here. We check to see all of these to print out other stuff. And then we can finally dump out this stuff. Again, the program itself is pretty simple here. It doesn't actually do anything super interesting. What's interesting is that using Manticore, they were able to write the script, which introduces taint of some variable. They've tainted it, and now they want to know all the things we can do with that. So if you think about what you could do with something like this, is you could set up and say, at this function, I control this argument. What does this what would this argument get me if I can control it? Now these aren't things like this are rarely useful for pwnables. It's relatively uncommon that you need to do solving of any sort for a pwnable. What it does come up with a lot is RE challenges. There are plenty of RE challenges over the years that you were able to, if you knew how to use it properly, just point anger at it and blah, here's a flag. It just spits it out. Hopefully, Manticore can do something similar. And at least to me, This looks a lot easier to understand than Anger stuff does. Like looking at the Anger stuff and getting all the environment set up and plugging all the pieces in and understanding all of their stuff, while it's a great thing and I'm really glad that they open sourced it and let people use it, personally, I find it confusing and hard to understand, so I don't really use it. Whereas this looks like something that I could get my hand around and be able to use on a more regular basis. So right now, I don't have any solid examples of doing that, but hopefully over the next couple months of playing CTF, there will be challenges that come up where I can actually use something like Manticore to do something useful, and I'll be able to talk about it more in the future. So, I think it's about all that I have right now. We went through big picture, we solved it, we landed a local exploit. We could have done a remote one, but I don't find that quite as interesting. Like we already have it working on one machine. Like I can go through the trouble of plugging all the different pieces in and using their libc and throwing it at them. But because we're not getting flags anymore, I don't know how useful that is to show. So we did that. We landed big picture, and we looked at Manticore a little bit and tried to see what I could do with it. Other than that, I don't really have much to do for tonight, so I think I'm probably going to call it a night a little bit early. Things to keep in mind, if you've stuck with me this far. DEF CON Quals is this weekend. You should totally play. It's probably going to have a ton of very hard challenges across probably a lot of ponables, a lot of RE challenges, but they usually do a pretty good job of including a whole bunch of non-RE and ponable challenges too. But I would expect plenty of hard challenges, lots of fun things to look at, hopefully really hard things to look at, and bash your head against it all weekend. And then next week, hopefully that'll mean I'll have plenty of fun stuff to talk about and say, wow, this was a really cool idea, or wow, that was a terrible idea. Why did they do it that way? We'll see. Other than that, Wednesday, we'll be going back to PDF Crack one more time, hopefully one more time, to actually land an exploit against it. And hopefully by the end of the day on Wednesday, we will have a working exploit against PDF Crack, our real-world bug that we had to cheat a little bit to make work. And after that, we'll be looking at Python for our future zero-day Wednesdays. I think that's about everything. The one thing that I do request is that if you are one of the people who watches my videos after the fact, you don't watch them live, please give me some feedback on Twitter about how you'd like to be able to watch them. I know that a big 2-hour video like this is pretty hard to sit through. Like, you know, if you are watching it straight through, that is amazing and you are awesome. But that might not be the best way for a lot of people to consume these videos and understand them. If you'd rather have them split up or tagged or things like that, send me a message on Twitter, let me know. I'd like to hear from people who are actually watching these, so that I know what is most useful to you, because me, I get most of my value out of just sitting here and doing them. Like, the value here for me was I got to land another ponable and take a look at Manticore, and while I did it, some people got some entertainment and hopefully some education out of it too. So whatever I can do to make it more entertaining and educational for you, I will try and do. So let me know. And if you have any other questions or comments, feel free to reach out to me. Thanks, everybody. Bye.